Well, I had a little camera trouble, so I'm going to have to catch you up on what I've done because I lost some footage. So let me show you where it's at right now. Well, you can see here I've got the new alternator bracket mounted where the generator was, and then the alternator mounted in on that. Then up on the head, originally there was a bracket between these two head bolts that allowed you to tension the belt for the generator. You have to pull that bracket off and then mount this new bracket between these two head bolts. That allows you to get your alternator mounted, and you just make sure your belt is in alignment with the pulleys and has the right amount of tension on it. Now I've got the new wire pulled in for the alternator and a new wire pulled in for the coil, but you can see the coil is not installed on the tractor right now. I'll show you why in just a minute. And coming back here, we've got the battery installed again, and now you'll notice the positive terminal of the battery is running down to the starter switch, and the negative terminal of the battery is now grounded to the frame. And here you can see two new wires coming off of my starter or ignition switch. They run down to the terminal block there with the ballast resistor in it, and everything is rewired, with the exception of knowing whether or not to include this resistor that comes in the kit. And all the instructions are going to tell you is if you need it to put it in, and if you don't, leave it out. So I'm going to show you now how to determine whether or not you need it. So to determine if you really want to use this resistor or not, you need to know how much resistance is in the circuit. What you're wanting is you want to try and get between 3 and 3.5 amps coming out of the bottom of your coil going down to your points. If you don't have enough amperage coming through there, you won't have a very hot spark, and the tractor may not crank or run very well. If you have too much amperage coming through here, you'll actually burn the coil out. So the range is between 3 and 3.5 amps. So to figure out how many amps are coming out of the bottom, you have to know how many volts your system is and how many ohms of resistance are in the path. So to figure that out, I've got this 6-volt coil, and when I measure for resistance, you can see I'm getting 1.3 ohms of resistance across the top of that. I don't know if you can see this page or not. Let's see. So on our 6-volt coil, it measures out to be 1.2 ohms, and then there's a 1 ohm resistor that's in the terminal block, and that stays in the tractor no matter what. And that gives you a total of 2.2 ohms of resistance if you just use the stock resistor and the 6-volt coil. So then if you divide your 12 volts by 2.2 ohms, you'll come out with 5.45 amps. So that's too many amps, and you'll wind up burning the coil out. So you would have to add a resistor in with that circuit to get the amperage down. Now this 12-volt coil measures out to be 2.5 ohms plus your 1 ohm resistor. That gives you 3.5 ohms. So if you divide 12 volts by 3.5 ohms, you'll come out to 3.42 amps. So that gets you in the golden range right there. So what I'm going to do is I'm not going to use this resistor, and I'm going to take the 6-volt coil that was on the tractor off, and I'm only going to use this new coil that came. Now the resistor that they sent in the kit was a 4.6 ohm resistor. So if I put 4.6 ohms with the 2.2 ohms that was in the original 6-volt coil, that comes out to 6.8 ohms, and I would only get 1.76 amps to my points. That would be a fairly cold spark and would not run very well. And you can see if I added that into the 12 volt system where I had 3.5 ohms of resistance already, plus the 4.6 ohms, I get 8.1 ohms. You divide 12 volts by 8.1 ohms, you get 1.4 amps. So with both of my coils, if I add this resistor in, I'm going to get too few amps going to my points. If I take this resistor out and I use just my 6 volt coil, I'll have too many amps and burn the coil. But I can leave this 12 volt coil on with just the stock ballast resistor, which is built into the bottom of this block right here, and I'll be in the perfect range. I'll have 3.4 amps. So I'm going to put the 12 volt coil back on there, and we should be good to go. I did a quick diagram of the wiring since I lost the footage. The way the tractor is wired, you have one side of your battery that's grounded, the negative. Your positive side of the battery now goes to your starter switch, and one leg comes off of the starter switch and goes to the starter, which is also terminated to ground. So when the starter switch closes, you get voltage to the starter and it cranks. Then we have a lead coming off of the hot side of the starter switch. That wire goes up through the back of the loop on the amp meter for the dash so that you can see the amperage, and comes up to the top lead on that terminal block with the ballast resistor in it. One lead from that junction block comes up and goes to one side of your ignition switch, which just does a make and break, and comes down to the now hot side of the resistor. That resistor comes and a lead comes off and goes out to the coil. Now, if we had to add a resistor in, we would add the resistor into this segment right here. But as you can see with the 1 ohm resistor that's in the terminal block and the coil, we get the right amperage, so we're not going to use a resistor. And then the alternator has a lead that comes back to the junction terminal on the terminal block, which allows it to backfeed down to the battery to recharge. So it's a very simple wiring on the tractor, and this creates us with a negative ground and an alternator versus generator. So let's get the coil on and see if the tractor will actually crank. Alright, the 12 volt coil's installed and wired up, and it's time to find out whether or not it'll crank. Let's see. That's all there is to it. The old 9N's got all fresh wiring and it's running good. So time to get some implements hooked up and start using it.